Today I'm going to talk about our subject topic torsion. I'll be your host who will guide you through its explanation. So what is torsion? Torsion comes from the word torque and is a result of torque applied in such a way so as to twist an object or a material. Well, this is the basic definition, so let's ask some other people and maybe they know something better about torsion.
Torsion. It's just a twist occurring due to the torque applied from one end to the other.
Torsion. It is something like twist, something like this.
So here is an average human being following his daily routine. But wait, did you see what he just did? He created torsion in the door handle to make it open. Oh no! But wait, wasn't this torsion in a way? These guys again? But look at the way they are twisting their towel, with one end fixed and the other end rotating. What a simple example of torsion. So now that the basics of torsion have been opened up to you, I'll speak from an engineering point of view and define it as a type of loading in which the stresses and deformations, or in other words, twist in a material take place if it is subjected to twisting couple moments or torques. This phenomenon is called torsion. It depends on major factors like the moment applied, the material used, and the section modulus. For a better explanation of this phenomena, I requested one of my colleagues to be here with us who has researched torsion and will explain it using a real-life example.
To elaborate torsion, I have chosen a very common machine, and I am calling it common because it has got an influence on every individual's life. I am actually talking about a simple analog wall clock. Now to see what is happening inside this machine, we have to actually open it. And the machine I was showing you in the wall clock is right now in my hand, as you can see. It's the front side, the back side. Okay guys, now we are going to see that how this machine actually works. First I am going to do is to display the battery. Okay guys, to see what's happening under the hood, what I'll have to do is to open it. It's a space of 1.5 volts battery. From this battery the power is first transferred to the PCB, the printed circuit board. From this circuit board it is transferred to this solenoid. The solenoid and this small gear is creating a motor like mechanism. You can see from its back side there is a magnet, a small magnet. Let me place this here again. Now you can see that the motion of this small shaft will rotate this transparent gear, and from this gear its motion is then transferred to the second one, and from this it is rotating the third one. Now let me open it. Okay guys, now I'll be removing this metal gear. Unlike these two gears, it has got a metallic shaft, as you can see right here. Now we are going to see what is behind this black casing. To see that, we'll have to first remove this motor. Again, I'll have to be very much careful because it has got a very small and thin wires, you can see right here, so these can break. So I'll be placing them aside. Now here's the turn of the black case. Guys, you might be thinking that in the start I was just talking about the torsion, but now I have not tell you any phenomena of torsion taking place within this device. Here is the turn of that thing. It's the blue gear in this way, and let me place it here. Another gear, the white one, it attaches the hour hand. Okay guys, now I'm going to tell you the phenomena of torsion taking place within this device. As you can see, the three hands of the clock are placed. I'm taking actually example of these three things because the phenomena of torsion within all the components of wall clock is prominent in these three. As you can see, the hour hand is connected with this gear in a way that a shaft connects the hour hand with this gear. Now to explain torsion taking place within this device, within this gear and pin mechanism, I'll be taking the example of Newton's third law, which states that every action has an equal but opposite reaction. So if by the power of battery, this gear is rotated in a clockwise direction, while the reaction produced by this pin will be in the opposite, that would be the anti-clockwise direction. So if it is rotating in this side, the reaction produced by this pin would be in the opposite side. So here is the torsion being acted on this place. Now let me take the minute hand. As compared to the hour hand, the shaft of connecting the gear and the pin is slightly greater. So the deformation would be slightly greater. But you will be thinking about that the deformation taking place within this device. Actually, we cannot see the deformation by a naked eye, but it actually exists right here. Now let's proceed to the second hand. It is connected to the metallic shaft. Again, the same phenomena. The difference is that in the second hand, in actually the hour hand and the minute hand, the shaft was made of plastic. Here is the metallic shaft. It's connecting the way. Again, every action has an equal but opposite reaction. The reaction of needle would be in the opposite direction, so the net torsion is acting on this place. Okay guys, that's all from my side. I hope I have succeeded in explaining torsion taking place within this device. Thanks for your time. Take care.
We talked before by relating torsion to engineering, and the reason we observe it is because it is a very common type of loading. If you open up a machine, you'll find torsion in so many places that it just might amaze you. Almost every machine designed has to have some sort of rotation of shafts. As you can see here, the max shear stress is related to the torque applied T, radius C and area spread J. Now the deformation due to this torque is given by the following expression of delta and then the design parameter of factor of safety. The applications of these formulas are seen using the example of this structural member of radius C, where we apply torque T on one end and keep the other end fixed. Witness the behavior of concrete of modulus G because it could not bear the maximum shear stress applied to it and deforms under torsion. So that's what we had to store for you in this video. Hopefully now you have a vivid idea about torsion, and I think I have conveyed all my knowledge to you in the most convenient way there. Thanks for watching, and I hope you found this video informative. Bye.
The peace could grow inside of you, in spite of me. Humanity, I hope you're out there somewhere. I hope you're out there somewhere. Right now, I'm all alone. I feel my time has come. Embrace the ending. I cannot take this pain. I cannot.